A little bit on the need for this webinar. We have scour documentation that appears to be lacking for a large portion of our bridge inventory, and we want to make sure that we address that we provide clear direction for scour evaluations, and then more so for missing scour POAs for bridges that are determined to be scour critical. Local governments don't always provide complete information to properly inventory bridges. So this the outreach to the ask to send this out to local governments was to help spread that awareness and increase awareness of the need to have complete information. Some scour evaluations performed in-house and by consultants are sometimes incomplete or overly conservative. So this webinar will touch on that and make sure that we're consistent across scour evaluations. And then finally, TxDOT staff aren't always clear on expectations for reviews. Our presenters today are Ryan Eaves, our state geotechnical branch manager out of Bridge Division. Chunh Lee, our scour engineer. He's really our lead technical resource with anything related to scour. He's a primary author for our scour evaluation guide and really takes the lead on updating our forms and making those changes. Yusuf Yurattas recently joined Bridge Division as a scour engineer, and he's definitely working with Chunh on our documentation, our policy, and quality controls. Mark Wallace is our bridge inspection program manager and bridge inspection branch manager. So he'll be talking about the bridge inspection side of things. And Bob Pearson, who is a bridge inspection quality assurance engineer, working under Mark Wallace. So with that, I'll pass it over to Ryan to start talking about TxDOT scour evaluation and scour coding.
Thanks, Stephen. I appreciate it. Let me get my presentation pulled up here. Okay. Let me know if you can see that, Stephen, if you don't mind.
We can see it.
Looks perfect. Thanks, I appreciate that. So I want to thank everybody again for being here with us this morning. We're excited to share all this information with you. So this morning, I'm going to start us off here by kind of giving an overview of TxDOT's scour evaluation program in order to just kind of set the stage for the speakers coming after me to go into a little bit more detail. So I'm going to spend just about everything you see this morning will be almost directly out of the scour evaluation guide, which I will link to here in a couple of slides. I'll be jumping around a little bit for continuity purposes, but you'll see once I get to that point that in the upper right corner of the slide, I have linked the location. So in case you're following along, you should be able to see roughly where I'm at within there. So just to give you a sense of where we're headed this morning in Module 2 here, I'm just going to give a brief overview of scour and why it's important. TxDOT scour program requirements. I'll talk about item 113 scour coding requirements. I'll give some examples of some kind of nuance within the scour evaluation just by providing some key examples. I will talk about scour critical structures and how those are identified and addressed. I will talk about countermeasure design and evaluation as well, and also how to code or how to manage the coding when a countermeasure has been installed. And then finally, I'll talk a little bit about some coding changes coming in the future and what that will start to look like. So scour, in its simplest form, just by definition, is the erosion of streambed or bank material due to flowing water. Now, this is particularly important for us at bridges because often at bridge structures, given the limits of the floodplain, we're contracting the flow at structures. We can't quite build bridges wide enough in order to avoid some contraction at the structure. And that constriction could also be vertically as well in the form of pressure scour. So just kind of in its simplest form, contraction scour, contraction scour at bridges can be an issue. So also pure scour as well. With bridges, we have obstruction to flow in the channel as well due to turbulence, either by debris or by the piles within that floodplain can result in erosion in and around bridge structures. So the scour is concentrated in that area. So it's important for us to be able to evaluate scour at those structures, and also to predict scour at these structures, so that we can one, design for them for new structures, and evaluate the performance of existing structures. So as I mentioned previously, so one of the big concerns with scour at bridges is foundation exposure, or loss of axial and lateral capacity. We rely on our foundation elements to provide resistance to movement of the bridge. So exposure of these foundations can cause issues. There's also structural concerns as well due to column buckling and slenderness, and we'll talk about how all of that comes into play. But the big thing is if I see something like this and I see some exposure, how do I know if it's an issue? Well, that's kind of where the Scour program comes into place, where I can determine, how much, whether or not, some amount of exposure is a problem or not. The other thing that's not quite as at the forefront in some folks' mind is erosion around abutments. We rely on our embankments to support a roadway just as much as we rely on our bridges to support the roadway. So embankment instability, which can result from scour, it is also something that is worth considering as well. Scour, if erosion around the toe of the slope, can cause slope failures, and undermining of rigid structures can cause exposure of the embankment behind it and erosion of that approach. So our goals with the Scour program is to predict and evaluate the effect of scour on bridges, and also to track the progression of scour over time. So again, as I previously mentioned, it's important for us to be able to, with our structures, to be able to determine, whether or not the scour that's occurring is an issue, or predict or determine whether there's potential issues with future scour. And we'll get into all of that as we go here. But again, as I mentioned, I'm going to be spending most of my time here within the Scour Evaluation Guide, with some reference to the Scour Analysis Guide as well. So I'm in Chapter 2 of the Scour Evaluation Guide here. And as part of our TxDOT Scour program requirements, scour evaluations are required for all bridges over waterways. So they must be coded for scour. They must have a scour summary sheet uploaded to AssetWise that includes the information and the documentation accompanying to support that coding. This is a requirement for new structures. This is a requirement for existing structures, both on system and off system. A scour summary sheet for a span bridge by itself is not sufficient documentation. It must be accompanied by a scour evaluation. We'll go into what a scour evaluation looks like here in the next few slides, but just to give you a sense, a scour summary sheet by itself for span bridges is not sufficient. For bridge class culverts, there is a different scour summary sheet, and in the forms section, Chunh is going to be going over more details about the forms themselves. But the scour summary sheet for a bridge class culvert satisfies both the requirement for the scour evaluation and the scour summary sheet, which we'll go into a little bit more later, but there's a little bit of a difference there for bridge class culverts. This is figure 2.1 from the Scour Evaluation Guide. I am not going to go through this directly here, but I just wanted to let you know that this resource is available. As we go through some of the information here with regards to the evaluation approaches and what forms are needed for different structure scenarios, this chart is a great resource to determine that, and it's kind of a good path to walk through in order to get to that point. Now, I'm pretty much going to cover just about everything on this, but I'm not going to cover this chart directly. This would be a good reference to have open while we go through this, if you're following along. So in its simplest form, for as far as evaluation methods or evaluation approaches, there's two approaches that we can take here. There's the field observation approach for analyzing scour and the prediction approach. So the field observation approach requires a couple of things. It requires that I have enough data and information in order to make determinations about scour, about the structure. We'll talk a little bit more about what that means. But this is based on current and historical performance, and we'll go through kind of the documentation associated with that. If I don't have enough information, or if it's a high-risk structure, or if it's a new bridge, as I'll talk about shortly, then the scour analysis or the scour calculation prediction approach is required for those structures. So that's an evaluation based on analysis using the hydraulic data and hydraulic calculations in order to determine the scour depths. So I'm going to start here with existing bridges. So in our scour guide, evaluation guide document, we have three methodologies listed there. There's the screening, which the intention is to identify and evaluate lower risk structures, which I'll talk about on the next slide. There's the assessment, which is a more detailed evaluation based on an extensive review of scour history. And then there's the analysis approach, which is, as I mentioned before, a detailed analytical evaluation based on a hydraulic analysis. So scour evaluation based on screening. This is the scour vulnerability screening form 538 is the reference here. Chunh will go over that a little bit more. Chapter 7 in the scour evaluation guide covers the how to fill out this form. But this is most commonly used for bridges founded in non-erodible strata. So the intention is to evaluate the bridge structure, assuming that erodible stratum is gone, or assuming that erodible strata is fully scoured. Is the bridge still stable with a non-erodible rock there? If the answer is yes, then we can evaluate that at the maximum possible scour depth and code it accordingly. If it is not, then we would move on to the more detailed scour analysis, more detailed scour evaluation with regards to the SV8. So scour vulnerability assessment. Essentially what we're doing here is we're trying to determine the scour vulnerability class based on the four criteria that I have shown here, which I'll go into in a little bit more detail. There's the channel material score, channel condition score, scour history score, and channel migration history score to determine that scour vulnerability class. And I will talk about how that comes into play as we start getting into the coding section here. But again, the scour vulnerability assessment is the entirety of Chapter 8 in the scour evaluation guide for reference. So I have included all of the associated tables with the four items that I had mentioned on the previous page. At the top left, we have table 8.1, which is a scoring criteria based on the channel material. So for this, I would be looking at existing borings, which often a lot of structures that we're looking at do have some existing boring information so that I can classify the material. If not, the web soil survey or site experience may be able to substitute for that. The SVA scoring criteria for channel condition is based on MBI coding 61, so it's a direct coding translation over to the score. The SVA scoring criteria for scour history is talking about our exposure categories, which I'll go into a little bit. That'll make a little bit more sense here in a few slides. But that's looking at the typically the channel profile measurements from bridge inspections. And then the same thing for the channel migration history. It's as a sense of whether the channel is shifting. You can determine that by taking a look at past Google Earth just to see if the channel is moving. And also, you should be able to find that out from the channel profiles from the inspections as well. So for existing bridges, structures identified as high risk, structures that are highly vulnerable to scour, and structures where I do not have enough existing information in order to make determinations. An analytical scour evaluation with calculated scour depths is necessary. And again, the majority of that is within the scour analysis guide from our H&H branch in the design division. We have a link to that for convenience on Chapter 9 of the Scour Evaluation Guide. For new bridges, there are a lot fewer choices. For new bridges, the scour analysis based on hydraulic and hydraulic analysis is required for all bridges. This is in section 2.2 of the Scour Evaluation Guide, as well as in the Geotechnical Manual. The contraction and pier scour is shown on the bridge here as an example on the scour data sheet in the plans, as Chunh will talk about a little bit. But again, this is required for all new bridges, both on system and off system. Bridges are also designed to resist damage resulting from the scour design flood as well. So often the depth of scour is, I say often, but the depth of scour is required to be disregarded as part of the design as well. So that may have, so we'll talk about a little bit how that may affect the scour evaluations moving forward as well. We'll talk a little bit about that, but I just wanted to point that out here first. Scour evaluations are also required for bridge class culverts. However, that is a different form. As I had mentioned before, scour summary sheet for culverts is Form 2606. And again, Form 2606 also serves as a scour evaluation. There is no supplementary form that's required for that. And we'll talk about that. The scour evaluations for culverts is strictly an observational approach. And we'll talk about that a little bit once I get to that point. Okay, moving on to the scour coding section here. As many folks probably already know, MBI item 113 is the scour coding. We have a couple of TxDOT tracking items here regarding the presence of a scour or plan of action, as well as unknown foundations. I am going to be talking about a new one, actually, unknown foundations. I'm going to be talking primarily about item 113 in this section, and I'll rely on Chunh and Yusuf to talk a little bit more about those other ones as they come up in future sections. So I have some coding definitions here for you. So I have them in a bit of an odd order. It'll make some sense as I go through this a little bit more as to why, especially when I get to the SMBI section. So I have the coding on these pages are kind of the identifier codings. So for example, we have bridge not over waterway, unknown foundation over tidal waters, the presence of countermeasures, and then also lacking scour evaluation and or documentation. So we have some number coding here and some letter coding associated with kind of identifying the situations at bridges. Same with coding of 9, all foundation components, including piles or shafts, are above floodwaters. Now getting to the rest, 8, 5, and 4 are a function of either calculated or both calculated and observed scour depth. 8 being there's minimal a minimal scour depth observed, or the calculated scour depth would cause minimal foundation exposure, down to a 4 where we're starting to get to the point where we're seeing some exposure. The bridge is still stable in this case, but there's enough risk there that action is required to address the observed scour. So we make our way kind of down towards the lower codings there. Starting at a coding of a 3, that is the point that by definition we're starting to get to the point of scour critical, or we're at the point of scour critical at that point. So once we start seeing major foundation exposure and or the calculated scour depth would cause there to be an instability, action is required. And I'm going to actually go into depth on these codings a little bit more as I get to the scour critical section moving forward. But the main point of kind of showing you this was to give you a sense that when I start referencing codings going forward and exposure categories and things like that, that you have a point of reference. Okay. So the next thing I'm going to talk about is the maximum allowable scour. So if I'm evaluating an existing or a proposed or a new structure, an important factor as part of this analysis is determining what the maximum scour can be, so that I can compare my observations and my calculations with that value. So that's what I'm going to be spending most of my time on here for the next 5 minutes or so. So I have this chart shown here just to kind of orient again the foundation exposure categories here. We use the terms minor, moderate, major, and extreme. Throughout the scour document, we utilize those terms intentionally so that we can, kind of pair them with other places in the document. So when I say minor, moderate, and major, those terms have implications with regards to exposure categories. So I just want to make that mention. And those are typically, and we have those based on our analysis tied to the Scour coding as well. For both calculated and observed. Now, there's a slight difference here, as we have seen, because from an observed, from a calculated or theoretical case and an observed case, we have kind of a different approach. So I'm going to go through some maximum allowable scour depth for some common foundation elements. So now here's a less common one, I suppose. So some of our existing structures have spread footing foundations with no additional deep foundations underneath. So when evaluating those structures, our maximum allowable scour depth, or the Y sub A that you see on the screen here, is the bottom of the footing. So if I see exposure of the footing, exposure underneath the bottom of the footing, I have exceeded my maximum allowable scour depth. For non-erodible rock case, we essentially say, for a rock that's determined to be non-erodible, we essentially say, as long as we don't have undermining, there's not any issue here. But for the case on the left where we have erodible soil or rock, we have our reference to our exposure categories there. There's the minor, which is the bubble 1, moderate, bubble 2, and major, the bubble 3 there. And so what we're trying to do there is to track over time the exposure of the footing. So if it does get worse over time, that we are coding it accordingly and that it's being prioritized accordingly. So as the footing becomes exposed, it will drop into that moderate foundation exposure. As half of the footing is exposed, it will drop into the major foundation exposure and start to require some action. Now, for most structures that you'll come across, it'll be a drill shaft or pile foundation. The maximum allowable scour depth for bearing or for foundation capacity is approximated to be half of the foundation length from the original channel profile. There's some nuance there sometimes when determining where the original channel profile was, or depending on maybe where the bottom of shaft is, etc. And we'll go into that a little bit. But the maximum allowable scour depth for bearing is half of that length. The reason for that is because it's actually quite a conservative assumption. The typical TxDOT design will design for a factor of safety of 2 or more. And so half of the shaft would exposure of more than half of the shaft would indicate that I am approaching a factor of safety of 1. Assuming that the soil is uniform for the entire depth, which is often a very conservative assumption. So again, this approach is quite conservative, but it is a valid approach for evaluation of a structure, given its conservatism. Now, in some cases, as I mentioned, there are ways that we can look at this if we have borings or pile driving records that we can make different assumptions associated with that. But again, this is the default assumption. Also, I have on this page as well, the original unbraced length also may govern the maximum allowable scour depth. Say if the unbraced length, the maximum allowable unbraced length, which I have some rules of thumb on this as well, exceeds the depth of the maximum allowable scour due to the bearing, then that will control instead. And again, all of this information is spelled out in the Scour Evaluation Guide. I'm just trying to cover it as best I can here. Okay, so now looking at this, we're pretty much looking at the same thing here, except now I have the exposure categories built in here. So we're looking at the same Y sub A. I'm going to start with the drill shaft on the left side because that's just as straightforward as what we had previously discussed. So that Y sub A is the maximum allowable scour depth, which is by default half of the length of the shaft starting from the as-built channel profile. I have my minor, moderate, and major foundation exposure. You'll note that the minor foundation exposure is Y sub A over 2, so it's the top quarter of the shaft up there, or the top half of the total exposure depth, or Y sub A over 2. And then I start getting down into the moderate and major foundation exposure below that. Now, looking at pile footing cases, it's a little bit different. It's you have to be a little bit more careful here because we need to very closely analyze what the approach was from the design standpoint here. So typically these footings, in order to be constructed, are excavated down to the bottom of the footing, and in TxDOT designs, we do not account for any bearing on the bottom of the footing. So typically, in that case, the measurement for foundation exposure starts from the bottom of the footing. The exception from that is if the channel profile started, above or below the bottom of the footing, then I would start there instead, which is that starred note down there at the bottom. So as I mentioned previously earlier in the presentation as well, with Scour, we're also concerned about abutment exposure. And so as I start to undermine the abutment, it starts to cause issues with erosion behind the abutment backwall. And so at that point, it requires some action, requires some remediation. So we have the major category starting when we see that the full cap is undermined, and you can see behind the cap there. So if the undermining extends to the embankment, we have now entered the major category, which will kind of push towards some action regarding remediation so that we don't have embankment approach issues. So here's kind of a modification to the table that I showed you earlier within the SVA scour coating section. So we have the exposure categories and conditions on the left side there. The minor, moderate, major foundation exposure. We have the countermeasure section, which I'll talk about when I get to that point in this presentation. But for minor, moderate, and major foundation exposure, we have the associated coding based on the normal versus enhanced scour vulnerability class based on the analysis. So if I have a higher scour risk, then there's the appropriate coding is dropped there. So I'm going to go into for pipes and box culverts real quick too. So you'll notice, and if you look in Appendix A, that's where this is for us. You'll notice that the coating is a little bit different. There are some coatings that did drop off in the culvert section, and I'll talk about that here in a second. But again, in this is strictly observational, and most of these codes reference the figure in Appendix A. And again, as you drop to a 2 and a 1, that reaches the scour critical threshold. And again, similar processes will take place at that point for bridges or span bridges as they will for culverts. And just to give you a sense of some of these exposure categories for culverts, again, this is in Appendix A. It is a function of the culvert undermining. So in the case that we have a culvert without a toe wall or an apron, it is a function of the culvert undermining, as we have shown in the figure here. If there is a toe wall, then it is a function of the toe wall exposure, starting from the bottom of the culvert, as we have shown here. If we have an apron, then it is a function of the apron undermining. And then if we have an apron toe wall, which is a case where I've got, scour fairly far away from my culvert, then I have a different criteria for that, or a less stringent criteria for apron toe wall exposure at that point. So just to kind of give you a sense of what that looks like, these are the current exposure categories for culverts. So again, just to kind of summarize here, so I'm comparing the maximum allowable scour and the thresholds within, and the maximum allowable scour is based on the foundation capacity and the structural capacity, whichever one controls, or column slenderness. And I'm comparing it to the evaluated scour. That can be the observed scour as part of the SVA or SVS, or the calculated scour as part of a scour analysis, and that is how I'm determining the coding for the structure. So next, I'm going to go through a few examples for some things you might run into with regards to evaluation and how to consider those. So one of the biggest resources that we will use is the channel profile. So in this case, the channel profiles, like the original in blue and the the current in red, this would indicate to me that there is roughly 5 to 6 feet of exposure, and that's what's shown in the scour depth here. However, if I go out into the field and I look at it, the inspector measured 3. And so why would something like that happen? Well, you know, the channel profile typically is taken from a singular location, and most often that'll be referenced on the inspection report, but most often it's the downstream end of the structure, which gives me information at that end, which often matches what's happening at the center of the bridge, but not necessarily always. And so the point of this here is that it is important to take a look at all of the information that we have, and in order to make that determination of what's happening there. So that's important. So it's not just a cookie cutter, like this one piece of information is all I need. It's important that we go through the history and take a look at this a little bit closer to make sure that we're coding it properly. This is another example too, where you know the inspection downstream measurement of the channel profile indicates that there is some change in the channel profile from the initial structure. This is a fairly new structure, and if you look at the inspection, we can see that there is little to no scour at all. And again, that's a function of the existing ground shown on the as-built plans being at the center line of the structures, and not necessarily at the edge where the channel profile is being measured. So that is something worth verifying in order so that we're not, you know, being conservative and coding something based on incorrect information. Another thing that I had mentioned before is often the scour depth is assumed in design. Now, this is something that can be taken into account in a scour evaluation as long as there is sufficient information in order to be able to determine that the designer did disregard that depth. So again, you know, you need confirmation in order to determine that the designer disregarded that depth, but we'll talk about that here in the next slide. So again, if there is a calculated scour depth and it is confirmed that the designer took that into account as part of the design, then the measurement that we're taking as far as the foundation capacity can be decreased at the bottom. So we'll talk about that a little bit more, but yeah. So if it can be confirmed that the designer disregarded the calculated scour depth, then the exposure categories will drop lower. Another thing is again, you know, if without any context or information, if I'm looking at these spread footings here, or if I think they are spread footings, then I see this exposure and I'm concerned based on the criteria that I had mentioned to you before. But again, you know, here very little scour has taken place, and there's piles underneath the footing here as well. So again, it's important that we verify that we verify that the ads built match what's in the field, and then also that we understand you know, kind of what the implication is from the as built plans. And so as I mentioned, yeah, so you know, the original embedment should count from the bottom of the footing, because again, you know, the footing was exposed at one point or another in order to construct it. The other thing that I had mentioned before is the half of the length capacity that I had mentioned earlier before with regards to the maximum allowable scour depth is a conservative approach. And so for structures like scour critical bridges, for example, we can take a look at the capacity and determine, well, in the case that we have in this particular case, that these piles were tipped in relatively hard material with high TCP blow counts. And we can also pull the pile driving records to get a sense to see if they're, you know, if a factor of safety of 2, like we mentioned before, is you know, lower than what we actually have in the field, and we can make those determinations. But again, that's something that we ask that you send to us in order to make those determinations as part of the, you know, as part of that. So scour critical. So by definition, classification for a bridge that is unstable or may become unstable as determined by a scour appraisal. So kind of by our coding definition, the observed scour depth in the major scour category, or the calculated scour depth in the extreme category, just kind of as a simplified section. The other definition is item 113 coded as a 3, a 2, or a 1. For a coding of a 3, that's often used when calculated scour exceeds the maximum allowable scour depth, but not necessarily always. There's a POA form 2604 is required. So again, action is required as part of that POA form. The coding of a 2, major foundation exposure from observed scour depth. Immediate action is required to remediate. This is something that we do not sit on. A POA form with a lot more form boxes in it is required. And again, this is something that we're asking now that we should be notified as in the scour.txdot.gov box so that we can evaluate it. So there's a lot of things that happen when a bridge is coded a 2, and so it's important that it's important that we're involved in that. Scour coding of a 1, extreme foundation exposure from observed scour depth has occurred. By definition, failure is imminent and the bridge is closed to traffic. And the POA form 2609 is required. Again, this is something that we want to be contacted immediately since there's bridge closure on the table there. And again, the big thing here is scour critical structures require action plans from the bridge owner. So again, it requires action. These are things that don't sit around and wait for follow up. Okay. Next, I'm going to talk about countermeasures for a few minutes. And again, another definition here for you, measures to improve or control stream stability and scour vulnerability. There's a number of different approaches, and I'm referencing mostly HEC 23, which I've shown in the bottom of the screen there. I'm going to talk mostly in this presentation here about revetment and armoring approaches. However, if foundation capacity is an issue, then foundation underpinning may be required in order to restore any lost capacity, assuming that I don't have, assuming that I'm below the capacity threshold for the structure. And then also HEC 23 references river training structures as well. Often these are a little bit more difficult in practice for us because often we don't have quite enough right-of-way outside of the bridge structures in order to be able to kind of change flow characteristics necessarily. So that's a little bit more difficult. So I'm going to focus mainly on the revetment and armoring portion. Just to give you some examples of things that we see at TxDOT. So concrete armor units or articulated concrete blocks, which are kind of semi-flexible, semi-rigid gabions and gabion mattresses, they work a little bit better in cases where you have steeper, where you're protecting slopes steeper than stone protection can handle. And then of course, stone protection kind of our preferred approach with regards to that because it is flexible, able to self-heal, thereby requiring a little bit less care and maintenance. So I'm going to make an emphasis here on countermeasure design. Countermeasures, the approach for countermeasures is that countermeasures should be designed, and that means details that is a detail sheet including a fully detailed plan and asset-wise. And as I'll talk about on the next slide, that has coding that has both safety and coding implications. So calculations are included also in accordance with design in HEC 23 and based on calculated hydraulic data or flow velocity at the structure, including the flow velocity at the structure. So the reason why I say this is there are a few risks associated with placing a countermeasure without running through the process of the design. If I am placing a material without any knowledge of what's happening with the stream or what's happening with the channel, the countermeasure may not be able to handle common flows. So if I place a countermeasure and I use that as place a countermeasure and you use that as justification to raise the coding so that I don't have to monitor it as much, I haven't really done anything because it's possible that it will not be able to, or it's possible, and I wouldn't know. It's possible that it may not be able to handle a common flow, and now we've got other issues. On top of that, countermeasures can have a negative effect on the structure if those effects are not evaluated. So placing something rigid against piles, which is the case that we had seen up in the top there, which caused some issues with that structure there. It can have negative effects on flow. It can also have negative effects on the bridge structure itself if not properly evaluated. And again, it might not fully arrest the scour, so it's much harder to judge. So Now I'll talk a little bit about kind of the coding approaches for countermeasures. Design countermeasures to address a calculated scour risk to get it out of the scour critical category. These can be coded to an 8 if the design documentation is included in AssetWise. For design countermeasures used to address an observed scour condition, the coding can be increased if the design documentation is included in AssetWise. So if I have, some foundation exposure, but I am halting that exposure using countermeasures, then often, depending on the magnitude of the exposure, that can be coded to either an 8 or potentially sometimes if there is, a reasonable amount, or if there is a reasonable amount of exposure to the point where the bridge is still stable, but there is some exposure, then a 5 might be more appropriate from a countermeasure standpoint. Not designed countermeasures, there is no immediate coding change. Again, we use the term designed and functioning countermeasures as a criteria for the use of countermeasures. So functionality must be verified by future inspections, and then this would be coded to a 7 once that has been verified, with future inspections. However, I'll make this caveat as well. The functionality of all countermeasures should be verified at inspection. So if even a designed countermeasure is no longer functioning, then the coding should be adjusted accordingly. So again, it's important that we're still checking that these countermeasures are functioning as intended as part of the inspection process as well. Okay, I will close out the presentation here with just giving a very surface level view of the future coding changes coming for the scour items. So the big change here, you'll notice that this looks very similar, at least in principle, to the item 113 coding. The big change here is that this is the BC11 coding is a function of observed scour. So you'll notice that the coding of 9, 7, and 6 no longer reference those indicators. They are part of the exposure, the observed exposure here. And the other thing is that you'll see here is that this coding isn't, and as we get to the next page, it isn't as directly tied to the scour critical as it is before. So for example, a bridge with insignificant scour could be scour critical if the calculated scour exceeds that threshold. So it's a little bit different here. So there's not necessarily a direct, there is, but there's not a direct link from this coding to a scour critical definition. That falls under the BA303 coding. I included this is directly transcribed from that manual. I just included it this way because it's a little bit easier to read. So for BAP03, the functionality is the scour vulnerability indicators here. So this is just kind of the indicators for the scour vulnerability check. So for example, it determines whether the scour appraisal has been completed or not, whether or not the bridge is stable for scour or not. If the bridge is not stable, then it is scour critical. And also whether there are countermeasures present or not, and whether or not those countermeasures have been designed. So this covers all of those items so that we don't necessarily rely on these items to cover all of those things. So I think that'll be much cleaner. And then we have a similar item to our 113-1 item here that essentially says, that if a plan of action is required, then is there one present or not? So it's it forms a similar function here, but it's an official FHWA item for BAP04 here in this. Okay, that is all I have for you in section 2 this morning. So I'm going to turn it over to Chunh to talk about the plan of action approaches, as well as some of our form requirements to kind of build off of some of the things that I've talked about this morning.
All right. Do we want to take any question or before, or you prefer?
I can. It may be easier to answer things in the chat for now, unless you have a preference, Stephen.
Okay, absolutely.
I'm good within the chat, and if there's anything that we need to come back to and reinforce or clarify, maybe after Chunh, then that'll give us an opportunity to do that.
Okay, that works for me.
All right, let me figure out my screen first. Can you all see my screen all right?
Yes.
Yes, sir. That's good.
And I assume you listen me well also. All right, let's get to the fun part of it. Make sure you have enough coffee. So I will go through a little bit of requirement of Scour documentation. I may not able to go into all the detail, but I just want to emphasize some maybe most frequent asked questions. So what I'm going to do is to do some revision for the needed document, and then run through some content that we should look for in a Scour document. Then I will go through some day-to-day work in terms of what we need to do. We need to redo a document, or our current effort and our current effort of tracking, updating, and storage of the Scour documentations. Okay, let's focus on the Scour documentation developed after 2020 and what supportive document we need to do. So Ryan kind of mentioned that for bridge over water, we subdivided the Scour evaluation approach by structure type. So span bridge and box or pipe culvert. For span bridge, this include arch culvert or bottomless culvert. So I deliberately put this wording of box culvert and pipe culvert here, because previously we defined it as a base cast culvert. So I will talk a little bit more about that distinction. Each type of structure have a different approach to address the Scour documentation. For all kind of structure, a Scour summary sheet must be included, because it will provide quick information for inspection need, whether we want to whether the inspection history, so there's a trigger pass, or any Scour condition change, that will have a quick give inspection a quick decision in a Scour summary sheet. Therefore, I will take a little bit more time to go into form content. Afterward, I will brief revisit all the other supporting document, which is this is each type, probably especially for Scour analysis, it will cost another big big time to address that. So I'm probably may not able to address all the Scour analysis. There is one case that we may miss here. This is the unknown foundation, which is somewhat fit into the old structure, but it is a little bit more different. So I will put this part in the Yusuf presentation later. Okay, bridge cast culvert. So item 61 has a number, or actually not equal to n, can mean all kind of culvert. Again, I want to emphasize this, only the box pipe culvert with a continuous bottom supporting the structure, that or impervious bottom, that we can use the 2606 form only, which is only by the observation, kind of like Scour evaluation. Bottomless culvert include arch culvert or free side culvert that do not have a continuous bottom, that we should consider as a span bridge. So, okay, let's go to the Scour documentation, useful content of the Scour documentation. So, Scour documentation should provide enough Scour-related information support the current Scour coding and future inspection. Not only this content will be needed for the purpose of tracking basis or check the box of fulfilling a requirement, but they also provide useful info for inspection, especially in the emergency situation. I think I mentioned that in the previous talk, and a decision for a re-evaluation. So let's go through them real quick. So I'm going to use our recent updated Scour summary sheet for illustration, because I also want to use this time to promote that our new form has been updated and ready to use They should be more user-friendly with all preset drop-down menu and the all the information that you need to code to decide the coding. And also we also include the NBI coding for preparing ourselves for the upcoming transition. So, all right, we need to make sure to fill out all necessary field in the form, like basic bridge info, Scour coding that will come up from an evaluation. Make sure information is consistent with other supporting document. So if we have Scour analysis, if we have inspection report, or we have SVA that we drop the coding from the SVA, we make sure we indicate the same number over here. So ELR's name, sign and seal, and date for tracking purposes. Type of evaluation analysis. So someone can trace what method has been used for the coding. Later, if any Scour condition change or maybe not consistent with the current evaluation, someone can revisit the Scour analysis or use the same method or a different method to do the evaluation. Okay. Foundation detail, whether it is assumed or no detail, please go ahead to include that. If we consider this is useful info for access or Scour for the Scour condition. This typically can be any maybe disregarded depth that in the foundation design, or like Scour depth, calculated depth, or any geotechnical conservatism. Because we can include that, we can deepen the allowable Scour depth that will be beneficial to the Scour weighting of the bridge too. We should also include any plan of action in the unknown foundation. So I provide a little bit drop down, add-on drop down. So that kind of this is kind of aligned with us as NBI's coding's recommendations. I will let Yusuf talk a little bit more over here. So inspection detail, which inspection we are referring to for the Scour assessment, right? We don't want to refer to an inspection that have no Scour maybe 10 or 20 years ago, or what kind of countermeasure condition in this bridge, or what kind of channel condition. All these number actually contributing to the decision of the Scour condition also. Scour depth section provide a very quick and hopefully a convenient summary for everyone's reference. So what is allowable Scour depth? What is the predicted? And what is the current situation, right? So we need to put it there. We rely on this depth to suggest a coding. So a good practice is to provide both elevation and depth. So again, it's a quick check, quick reference, so people can, anyone can, revisit it and then pull out the same number for a check. So another important element is the trigger elevation or condition. For interior band, likely we do the trigger elevation, right? For the abutment, we typically just only rely on the trigger condition, which is Ryan has mentioned that maybe the bottom of the abutment cap, or any toe wall in the concrete riprap has been scoured. This provide inspection to know when exactly we need to re-evaluate Scour condition or Scour coding for a bridge. A good practice again is provide both elevation and depth. Tricky condition abutment should be considered too, right? When a Scour depth meet or pass a trigger, that means the structure will need to be re-evaluated for Scour, and a new form should also update it. So another good practice is to attach a graphical trigger in a Scour summary sheet. I think it's especially convenient for Scour critical bridge when you know, a timely inspection or action is required. This is provide an engineer a quick reference. So this is in one example, and you can do you know, this is another example that can show you what, you know, the graphical display would look like. So let's go to the supporting document. For new span bridge, we have to do a scour analysis. So why? Because we don't have any inspection history to evaluate scour vulnerability for a channel. Also, from the preventive standpoint, right, the best countermeasure is actually to include the predicted scour gap in the foundation design. So I saw a question in the chat that whether we need to do scour analysis for West River, or maybe. So I would say yes. So even though, you know, a scour analysis you may understand that we maybe not have nothing, but we have a document to say there's no scour at all. That's beneficial for us to take a look at it later on. So I will not spend too much time on what we need in a scour analysis report, because again, this is a big topic, maybe cause another maybe another webinar to address that maybe better. So please refer to chapter 2 of scour analysis guide developed in a hydraulic section for detail. So I want to emphasize when reporting, we want to make sure the report provide enough info to come up with the same result, or, you know, to be available for someone to check whether this is like a too aggressive approach or conservative approach. Again, here's a laundry list provided in chapter 2. I'm not going to go through it. I just want to emphasize, you know, the scour calculation method summary of a table for showing the contraction, pier scour, and total scour would need to be in a scour summary sheet. A fixed hydraulic report or scour report may be easy to lost somewhere, because it typically may be not included in a plan submittal. So a scour data sheet may be a good alternative. This can refer to the chapter 7 of the latest bridge design guide. I want to emphasize that a scour analysis plan should be a standalone summary sheet. We need to be aware that we do not want to display scour depth on a bridge layout, because it is not a part of information to build a bridge. And also, it may create confusion by telling, you know, others that scour depth profile has been considered. So below is a checklist. I will not gonna do go through it. Please just refer to chapter 7 of the bridge detailing guide. And you can also find this example sheet in the guide too. All right. So for all span bridge, we treat it a little bit differently. Of course, we can also have an option for scour analysis if we think it's necessary. I intentionally to use the old instead of existing bridge because it seems a good differentiator to remind us that the need for inspection history. So I'm not planning to go through all form here. Rather, I would want to spend some time to, you know, decide what kind of document we should look at. So for all span bridge, first we need to differentiate whether it is a erodible channel or non-erodible channel. So let's focus on erodible channel column first. So for non-erodible channel, again, we want to make sure we have enough channel history for our reference. If no, it means we want to pursue a scour analysis. And then once we perform the a scour vulnerability analysis using the SVA form 537, then we want to make sure whether the structure is critical or not. So if both scour vulnerability and the roadway criticality seems very high, I think it is worth to pursue a scour analysis. So for Allowable channel, that is not old enough. We need to pursue a scour analysis, of course. For bridges not old enough, that may also indicate, this is a newer bridge that we may have chance. The scour analysis stored somewhere, maybe in your office cabinet or having been uploaded in the drive. So this is why I mentioned previously, the scour plan sheet may help to resolve this issue. I'm not sure it may future is really a solution, but I think that may be a good solution that scour plan sheet it can resolve this problem. So because scour plan sheet, we can have it is included in the plan set, and then if we upload it to SFY, that will be one singular source that we can find it out. So I saw the chat asking when we need to do SVA and when we will do SVS. So I just create this PowerPoint last minute. So for non-Allowable channel, right, that the Allowable strata can be very low, maybe toward the end of the tip or pay foundation. Then we don't want to call it as a non-Allowable channel. So there is an indicator by comparing the Allowable depth and the scour depth to come up with number when we should use form 537 for SVA. So this table is included in form 538 in the SVA form. So when SVS form. So when you go through this table, then you can make a very distinguished decision when we should use SVA and SVS. Again, a more comprehensive decision can be referred to the scour analysis guide 52. So all scour form can be found in our scour website, and again, I already upload all the new form. Bear with me, I haven't get to the guide yet. I will commit myself to update the guide and upload to there also. So when we should update our current scour documentation. So we mentioned that a scour that meet or pass as trigger, we should upload and update our scour documentation. Right? There are other situations that we need to consider to update our scour documentation, right? Such as the evaluation method change, when an unknown foundation become known, either by NDE or non-destructive method, having a better assumption of the foundation, or we can find out the plan later from somewhere, then we should consider, what we do the scour evaluation. When the bridge is widening, a bridge is widened is considered as a new bridge, so a new scour analysis should be needed. So bear in mind that this message have to pass to the local bridge owner, city, or remind ourselves, this is really needed for scour analysis when the bridge is widening. So scour condition change due to design countermeasure install. We can raise our coding. Scour problem maybe reappear in some different band or even extend to abutment. Then we need to update it too. So, excuse me. In our scour guide, we also allow some existing document if it remains valid. So we need to check whether this document has all required or useful Scour info available. Evaluation is remain accurate or not, or be able to support the Scour coding. Is the method of evaluation can be traced, or who should I contact for for the assessment? So all right, let's take a look at one example. This assessment is a standalone Scour documentation. I could not find any other supported document when I searched the asset wide. It was dated 10 years ago. We cannot locate the evaluation for supporting the coding. So here is that need analysis. I think probably again that's one of the case. Maybe the file maybe in someone's cabinet or in the drive may haven't been uploaded. And I'm not sure when what inspection is referring to. That's not good. So also previous Scour assessment did not include the abutment condition, but just here is all the interior and band assessment. So with that, we understand we have a need, right, to track our Scour documentation and perform update. We have 3 systems. I think most of you experience enough about that. So I will briefly mention this 3 system and talk about a little bit nuances. So we have monthly Scour report or future like dashboard. I will show you from Stephen's email. Just keep tracking on it. List of structures, especially in Scour tab, provide a little bit more information, and the QC folder in asset wide. So for monthly Scour report, we try to identify base coding only. Okay, item 113.6 and item 113.1 have a blank for a Scour critical bridge. But of course, in the beginning of the year, I do a little bit favor for everyone to run a query to compare the coding, whether the Scour file exists in the asset wide. If not, I switch to coding. Then I will continue to do every month. So later on, so we will bring the coding pretty much the same. But again, monthly Scour report only search for the coding. It do not reflect any changes of Scour documentation or any need for the new Scour evaluation. And okay, I also use this time to promote this monthly Scour report will be transferred to the dashboard later. I don't want to provide too much detail on this because this page may be changed from now to the actual upload. We are in the progress of moving this to dashboard, and hopefully this data will be useful for everyone for timely address the issue. Basically, the dashboard have 3 tabs. A summary tab for all district, reference about the number, and then we have the detail tab that you can filter your district and the data deficiency. Then you can pull the entire list of structure for follow-up later. And of course, we have a history tab to track the history of performance. So the second way of actually is more comprehensive is the list of structure spreadsheet. That include identifying the Scour critical bridges, missing Scour documentation, change in Scour condition, and a suggest of a new Scour summary sheet and evaluation. So this is very comprehensive one. The third method is the QC folder. We provide quick yes or no answer about whether the Scour documentation is legit or missing. I will hold, please hold any question a little bit. So I think Bob will cover that a little bit more in his section. So to help us to be effective to trace and tracking all the documentation, please make sure all the Scour documents and name it properly under the asset-wise naming convention. So later on, I would do another, query or like sanity check for Scour summary sheet, so that any structure that missing a Scour summary sheet will pop up in monthly Scour report too. Also make sure it's stored in the bridge attachment folder, and then archive all the old file to the archive bridge attachment. That will help us to save some time for that. So in summary, please continue to hear the Scour documentation flowchart in chapter 2 of our Scour Evaluation Guide for proper Scour documentation. I know there is sometimes some nuances, whether it's the new bridge, the old bridge, what kind of evaluation we need. Maybe there is some cases for the evaluable or non-evaluable to decide what kind of document needed. Please don't feel hesitate to reach out to us for questions. So Scour summary sheet will provide a very convenient and useful resources to the inspection folk, but we want to make sure the info is useful resources. When Scour coding or condition change, we need to update our Scour documentations. We have a good system, but of course, maybe not perfect for tracking Scour deficiency. Please continue to follow the Scour monthly report or that Stephen every month sends out. List of structure at Scour tab, and later QC Scour documentation in asset wise. So I conclude my section at this point. All right, this section should be a little bit easy because the previous 2 sections has laid out most of the concept. Some content may need a little bit, maybe have a little bit overlap, especially come to the tracking standpoint. I will cut it short when we get there. So I will talk about why and when we need a POA and kind of remind ourselves the meaning behind it. And then we will get to some detail about POA. Afterward, I will walk through what is our current system to track and review the POA. Okay, why and when do we need a POA? A bridge is considered Scour critical if observed or calculated Scour result in major foundation exposure. Ryan is kind of mentioned it in the previous module. A little bit recap in graphic. So when a spread footing got undermined or a deep foundation system have excessive exposure due to Scour to the point of 3 and 4, I mean the major foundation exposure and extreme foundation exposure. Or in case of abutment, undermining our abutment cap. Or in case of culvert, I just saw one can over here, undermining a culvert and more. Actually, there's one more I would let Yusuf to talk a little bit more in his section, is when the unknown foundation found in a high width, then we need to probably think about this as a Scour critical situation. So why we need that? Why we need a POA? National Bridge Inspection Standard (NBIS) require, develop, and implement a POA for a Scour critical bridge. The purpose of a POA is provide safety of the traveling public and minimize the potential for bridge failure by taking corrective action. I would also say timely taking the corrective action to address the Scour issue. In TxDOT, we need to fill out a corresponding forms for Scour critical bridges for item 113 equal to 1 to 3. Their respective form here provide different degree about plan of actions. Each action, if this has been physically implemented, such as maybe flood monitoring, repair, closure, or reopen, should be tracked in a POA forward form 2607. All right, let's go through some requirements. In terms of content, a POA should address Scour problem by providing monitoring structures, a proposed countermeasure. Note that the monitoring is also considered as a countermeasure repair, but the monitoring schedule cannot waste like a Scour coding. So that's why we know sometimes we need to consider repair and construction. So the construction schedule in POA, closure instruction, and each POA should be done by multiple parties to agree with the detail. That include the TxDOT or the other bridge owner. For monitoring program, the goal is to provide the frequency and type of measurement to facilitate early identification of potential Scour problem. And of course, provide specific instruction is very important, okay? So let's take a look at one of our form 2624 as an example. So under the monitoring plan, we need to provide frequency and type of measurement. And of course, each measurement, you will indicate, specific instruction what you need to do, whether maybe an excessive settlement observed, any passive trigger, what happened to the overtopping occur, etc. If the bridge is going to be repaired, so who is responsible for it, and what is the construction schedule? I need to list it out. Again, if it will become a replacement, who in charge, and this construction schedule. So when the monitoring become, design the bridge need to be closed, who is the immediate contact, or who are the immediate contact for the closure and reopening? This is also particularly important when an emergency happens. We want to save as much as time to address the closure and coordination before anyone can drive on an unsafe bridge due to Scour. And of course, after the closure, what alternative route and its condition should be think ahead. A summary of outlining is very helpful too for the coordinator, anyone that can know what exactly we have been planned and what exactly you need to do. That's help the coordinator to reach out to the emergency team. And lastly, this POA, again, we need to agree with multiple party. More example is available in the Scour website. I am behind to use the new Scour form to update these example. I will do that as soon as I can. So I'm doing some Scour audit this few months, and I found this kind of Scour memo that consider as a POA previously. I want to emphasize that Scour memo is not considered as a POA. So mainly because I cannot locate the content of the POA, such as the monitoring instruction, proposed countermeasure, or other construction schedule that we mentioned, right? And also this is very old, and I'm not sure it is there, and I cannot locate any file in AssetWise about addressing the issue, although it indicates file stored somewhere. So if your district may have those files, please upload to that. POA is very important to be accurate and to be available for a Scour critical bridge. This is, again, this is for the reason of public safety. One way, we don't want a bridge that is not scour critical to be coded as scour critical. This can save emergency teams time to reach and take action to the real scour critical bridges. And it's also helpful to the inspection prioritizing and stay more focused on the real scour critical bridges too, right? So on the other hand, we don't want to miss tracking a real scour critical bridge. So here is some 3 basic steps we currently have to review and tracking the POA system. So step 1, as we mentioned earlier, we should be a little bit skeptic for a bridge is coded scour critical, or whether even though they're within the scour critical category, like 3, 2, or 1, whether they situated in a proper number. Okay, so step 2 is we want, if a bridge is real scour critical, we want to make sure a POA is uploaded to AssetWise ASAP. We want to aim item 113.1 POA is on file. Step 3, so we want to make sure the existing POA reflecting the current scour condition and update. So let's take a look at the first criteria. Okay, we kind of mentioned it, but I just try to summarize again to emphasize the importance. So I will not spend too much time. We may want to check the SBU channel profile, whether it match the inspection profile. Inspection typically may drop a tape or downstream or upstream, right? For the scour measurement. Sometimes inspection have photo of measurement while a bridge channel profile may take the like surveyed in the center line of the alignment. The grade difference can be significant. So, and the second thing is whether we can confirm the design, consider any disregarded depth, whether it is due to scour, geotechnical conservatism. Is the scour channel stabilized? Sometimes the scour is happen significantly in the early age of a bridge, but it may be wash out the surface erodible material, but afterward the scour can stop for a year. And the scour condition remain the same for years. So whether it is stabilized, that so it is worth to check the weight of scour, right, in the inspection record. So it's a structure or geotechnical capacity compromise. Again, this can reach out to our group to for cost check. Lastly, whether the previous scour analysis is too conservative, right? So sometimes in the old time, we just have PAC 18. We don't really do a lot of like spherical analysis for clay, or even not doing any like rock scour analysis. So we just really rely on PAC 18 for sand, and then a lot of channel probably assessed by using sand material. Then that will have a lot of like conservatism over there. So therefore, we want to make sure everything it is matching the scour coding. If you have any question about that, please feel free to reach out to us and then decide that. The second step is to make sure a POA is uploaded to AssetWise. That's pretty much the same. We need to follow the naming convention, and also follow the monthly scour report list of structure or QC report in AssetWise. Again, make sure the name right. Follow monthly scour report. Again, this will also appear in the dashboard later. I will not go on top this again. So the third thing is ensure existing upload the POA item 113 EQP is current. Similarly, we just follow monthly scour report list of structure and QC report in AssetWise. I want to just tell you what I'm doing also. On top of current system, right? Myself is reviewing POA that is developed before 2020. Why? Because 2020 is the rough cut line for our more official Scour program setup. The idea is to gauge what need to be updated. We found about a total 219 structures that the PO named or uploaded before 2020. I'm about 64 structure reviewing this month. We plan to reach out each district to address and review the comment. Basically, if you receive my email or Stephen's email later about this, you can just look at column R for N and M. That meaning the Scour POA not updated or maybe updated. And then under column S, if I advise yes, that means we need a new Scour evaluation. I encourage the district to do this exercise. I think we can remove quite some of the Scour critical bridges that were coded Scour critical, probably because not enough of inspection history before, but now we have inspection history now. So in summary, POA improve safety of the traveling public and minimizing the potential for bridge failure. So POA is needed when item 113 less than 4. Again and again, follow monthly Scour report, list of structure QC folder, and that's and you know the email upcoming that I will send to you guys. With that, I conclude my presentation here.
Thanks, Chunh. I guess we can go right into Yusuf, who'll be talking about unknown foundations.
Can I do a sound check and screen check? Can you hear me?
Looks good.
Me? Okay, awesome. Good morning, everybody. In this section, I'll talking about unknown foundations and more details. So we'll give the method set available to address the unknown foundations and introduce the risk-based assessment to categorize the unknown foundations even further. Chunh mentioned the plan of action and upgraded item 113 form. So I'll be touching those one more time, specifically for unknown foundations. All right. Scour Evaluation Guide Chapter 6 is dedicated for unknown foundations, and most of the information I'm going to present today can be found in Chapter 6. Just letting you know that I'm referring to Chapter 6 pretty much all the time. And we define there unknown foundation as any foundation with unknown composition, gross dimensions, or embankment. Here I show an example bridge that is a simple span bridge built in 1959. The foundation can be verified visually, and the inspection report shows up to 1.5 of Scour. So unfortunately, the plan set is not available, therefore we don't know the pile embankment depth. So even though we know some level of information about the foundations, we are missing one vital piece, and therefore this bridge is classified as an unknown foundation. So item 113.2 is equal to U. So so if the problem is and because of the missing information, so the solution is maybe find that information. So the very first step to address the unknown foundation is to go through a data collection process. Can we get the as-built plans? Can we get the pile driving records or any relevant bridge information so that going to be helpful for us to complete the Scour evaluation. This means going through the archive, going through the files, and it might be tedious sometimes. I'd like to take a couple of notes here. So TxDOT's microfilm records are currently being digitized, and they are available as PDF files. So they are widely available and easily available to all the TxDOT employees. So all you need is just to submit an IT ticket for a specific microfilm, and all the content of that film is going to be sent to you as a PDF file. So that is pretty convenient, and I suggest everyone to take advantage of that. Also, when we talk about unknown foundations, a big majority of the unknown foundations are actually off-system bridges. So we all need to request the as-built plans from the local agencies, local government, local authorities. So we have a better chance of receiving the as-built plans from the off-system bridges. And the second method to address unknown foundations is assumption and inferences. So we can assume some embedment, foundation embedment. Chapter 6.3 frames the assumptions we can make by default. So for verified deep foundations, the 10 feet embedment, and unverified, if the deep foundation cannot be verified, or the spread footing, so we can assume 2 feet of thickness and then 1 foot of embedment for the spread footing. On top of that, we can infer the bridge foundation embedments based on the similar bridges. If there is a sister bridge close by in the same vicinity, maybe built in the same time, maybe by the same contractor, the similar structure. So if there are so many similarities, we can assume that the foundations are going to be similar too. But if we are going in that route, so need to provide the justification for the assumption and provide the documentation for that. And finally, and the third one is the non-destructive evaluations to address the unknown foundations. Those are the test methods to determine the subsurface bridge bridge foundation characteristics, such as foundation depth, type, geometry, materials, or integrity. When it comes to Scour evaluations, pretty much the foundation depth is our only interest, and we are trying to get that information. There are different types of tests available. Case specifically, we can choose the best suiting one and then perform the NDE. So far we talked about the different types of methods to address the unknown foundations, and the question now is, how do we know to choose or when we use which one when? And that is going to be based on a risk-based assessment. We have a risk-based assessment tool that estimates the annual probability of failure of the bridge due to scour, as well as the minimum performance level. And comparing these two values, we are defining 3 different categories. If the ratio, the probability failure to minimum performance level is less than 1, that is defined as the low risk category. If it's greater than 2.5, that is a high risk category, and anything in between is the medium risk category. So we have 3 different risk categories based on a risk-based assessment. So a quick note that the high risk doesn't necessarily mean scour critical. All of these risk categories are way before the scour critical stage. But we can say that with this tool, we are predicting that the high risk bridges are more likely to become scour critical than medium risk or than the low risk bridges, so that we can prioritize which bridges to address first. This is the tool. It's one page document that is available on our Scour website under the risk screening for unknown foundations tab. And this is not a brand new form. It was available used before too. We recently updated it, deleted one section, so it was before both assessment and then Scour estimate for the unknown foundation. So we deleted the Scour estimation part. We are leaving that now for the users. So this tool is only for the risk-based assessment and to identify the risk category. And what that tool does, here again, the same bridge that I'm referring to. So the tool requires some input data. We are providing MBI condition scores for item 26, 60, 61, and 71. So all we need to do is to enter those numbers here. And in return, the tool calculates the annual exceedance probability and minimum performance level. And the ratio of these two numbers is 0.5 for this specific bridge. And if you remember, 0.5 is less than 1. So therefore, we can further classify this bridge as a low-risk bridge. Looking at the overall picture, so how it looks like. So we ran some numbers back in February to see the bridges, and for about 120 of our all unknown foundations. So for the all foundations that is called U currently unknown foundations, 120 of them is high risk bridges, corresponding to about 2%. So 6% is medium risk, and the 93% is low risk bridges overall in Texas. Okay, now again, we mentioned the methods to address the unknown foundations. Also, we talked about the risk categories to further classify the bridges. Now let's combine them together and see a map how to address the unknown foundations. If an unknown foundation is identified as low risk, so the very first thing to do is we go to data collection process. Let's find out the plan set and be done with it. If that's not provide any results back, we can assume data according to our Scour Evaluation guide, or infer data based on the supporting documents based on the similar bridges. For medium risk bridges, the process is pretty much the same. On top of the low risk for medium risk bridges, NDE is now an option too. So we can, if there is a necessity for it, we can do NDE to perform the Scour Evaluation. However, when it comes to high risk bridges, again, the data collection is always our first route to go. We are trying to find that plan set first. However, if it doesn't return any results, now the NDE is our now only option to infer data. So we can not say, okay, I want to assume that 10 feet of embankment now. That is not an option anymore. NDE is pretty much the only option to infer data for high-risk bridges of unknown foundations. Meanwhile, moreover, so until the NDE is performed and Scour Evaluation is done, a plan of action has to be in effect. So we don't have a score for those bridges yet. So we are considering the Scour critical and provide the Scour critical plan of action until the further NDE test is done and then Scour Evaluation is performed. And in terms of this documentation, so Chunh will talk about the documentation. We are providing Scour vulnerability assessment and Scour summary sheet for the Scour Evaluation documents. For unknown foundations specifically, we need to attach that risk assessment form to SVA form. Okay. So now plan of action for the unknown foundation. So if the Scour Evaluation cannot be performed after the risk-based assessment, that is the high-risk bridges for us because it requires a NDE, a further action. So a plan of action needs to be developed, and that plan of action needs to be Scour critical. Well, as I said before, high-risk bridge doesn't necessarily mean Scour critical, but we don't know because it's not evaluated for Scour. And for this case, we are assuming considering the Scour critical and providing the plan of action similar to Scour critical bridges, and that can be from 2604 or 2624. That we left that open-ended to decide case specifically, and you can judge based on there. And that plan of action should include similarly monitoring more frequently in that foundation investigation, that is an NDE. So plan of action is deferring NDE, and NDE requires the plan of action. So that's kind of circled here, and design and construction of a bridge or countermeasure. And as a summary of everything, so the unknown foundations and documentation and the addressing the unknown foundations, this is a flow chart. retrieving the plan set is first route for any case, and then risk based assessment to further classify the unknown foundations based on the risk categories, and from the risk categories we go from there, either assume data used for the evaluation or NDA is required for an Scour evaluation. So the unknown U, we are using the code U in different places. So I want to kind of show them all together here and summarize and what is going on. So MBI item 113 has a U, so that is unknown foundation lacking Scour evaluation and documentation. In our Scour forms, we have item 113.2, so that has two options, blank meaning known foundation and U meaning unknown foundation. But now we are updated our forms and we updated our 113.2 definition too, and we are adding more options to that code. Similarly, blank means known, U means unknown foundation and lacking Scour evaluation. A means it is still unknown foundation, but the foundation that is assumed based on our guide. On NDE means is an unknown foundation, but the foundation that is inferred from an NDE test. And to reflect that change, we are going to make a bulk change on asset-wise and changing from item 113.2 from U to A for all the unknown foundation that has a Scour evaluation currently. So, and if you are accustomed to put U for unknown foundation previously, just know that U has now a slightly different meaning and we have more options. And well, the drop-down menu on the new form is going to be helpful. Yeah, that's it for the. So let's go back to our bridge one more time. So this is the bridge and it has an unknown foundation. We did the risk assessment and then this assessment turns out to be a low risk bridge. And the current coding for this bridge is 6U. So item 113 is 6 and the for unknown foundation it is unknown U. So what can happen in the scenario, first scenario, the district goes do some data research and hopefully finds the plan set and finds the actual depth of the foundation and then get rid of these unknown foundations box. So this is blank, meaning it's known now, and this Scour condition is possibly 8 because of the 1.5 of Scour. So that's a rough number. Or if the data search doesn't give any results back in the second route, so they can, so this is unknown foundation, and since the risk assessment turns out to be low risk, so they can assume the depth, and based on our Scour guide, that is 10 feet. So now A means unknown foundation, but the depth is assumed based on the guide, and then Scour rating is possibly again an 8. And that is it for me. Thank you so much, everybody.
Thanks, Yusuf. As a reminder, we've got a few questions in the chat box. If you've got any questions, feel free to add to that, and we'll be monitoring that and start responding to those that haven't been responded to yet. Next up, we've got Mark Wallace, who'll be talking about the bridge inspector requirements. And with that, Mark, please share your screen. We can see you.
Okay, thank you. Let's see. Just a minute. Okay.
Mark, you're coming in a little bit soft.
Yeah, I'm sorry. I was mumbling to myself, trying to get this slideshow started. Okay, how's that look?
Looks good, thanks.
Okay, good deal. All right, so I'll be talking about bridge inspector requirements, but I'm also going to touch on Scour itself and why it's a big deal. So here's just some examples of some conditions, you know, that we can run into when we have high flow events. Here's approach roadway that's been overtopped. You know, and you can see this rather large scour hold on the downstream side of this pavement. And water obviously got underneath the roadway here. Appears to be a pretty good cavern underneath here. So, you know, it can do considerable damage. When in the right stream beds, high flow, you know, will chew away at the banks. And if it's a wooded area, all those trees right at the edge of the stream, you know, a lot of them will wind up in the stream itself and wash down stream until they get to something like this bridge here. And you start blocking the hydraulic opening underneath this bridge. So the presence of the drift doesn't change the amount of water that's flowing past this point. So what absolutely has to happen? I mean, it's just there's no way about it, or no way around it. When you reduce this area, you know, the same amount of water is coming through a smaller opening. So essentially, what you're going to have is an acceleration of the water. The height of the water will rise a little bit. It's going to neck down. The cross section of the water will neck down, and it is going to pick up speed. And this is not the same bridge, by the way, but very, very similar situation. You know, here's the opening where the water can get through. It increased velocity significantly, and you know, here's the abutment that's now exposed, and the approach slab here is undermined. Guard fence posts kind of dangling in the air here. And also, we did have unfortunate event in 2018. We lost a bridge in Kingsland, kind of near Marble Falls. That's northwest of the Austin area. Luckily, that bridge got closed prior to it collapsing. There was, just to give you an idea, there was a 40-foot rise in the water surface. So that water was screaming down the Llano River. A lot of rainfall in the Llano River basin, you know, and it all came down Llano River, passing under our bridge that was here at RM 2900. Took out all these spans. The bridge was built in '69 and had been performing perfectly. In fact, the year before this collapse, the routine inspection, you know, there was a plot of the channel cross section, and it pretty much is identical to the original construction, you know, the elevation of the channel bed at that time. And so what occurred was all this material here was carried downstream, and eventually, you know, these piles, they just lost their capacity to hold the bridge up. There's tremendous lateral force on the bridge due to that very fast moving water, a little bit of drift, all that. And so the piles, you know, there was nothing left to hold the piles in place. There was a couple fortunate videos. One, there was a news crew that was on site while at the exact time the bridge collapsed. So let's, I know videos are always kind of a, maybe don't always have good luck with them, but we're going to give this a try. What's interesting to me, hopefully you'll be able to hear it in the audio, is you can hear on the old T1 rail that's on this bridge, you can hear that rail coming apart, snapping at the bolts. at the joints in the rail as this thing is starting to come down. And there was also fortunate that I have no idea who this guy was. Some random fellow was out there. He was downstream a few hundred yards, I suppose. Had seen the collapse and had his phone out and caught this video, which is to me pretty impressive. So scour obviously is in this case, you know, you can have something that occurs quite rapidly, or kind of like Ryan was speaking to earlier, it can be kind of more cumulative damage, you know, occurring a little bit at a time over some period of time. And here is why, really the heart of why scour is so important and why we spend so much effort on it. 85% of the bridges in the country in some form or fashion cross a waterway. And in the US, flooding and scour, essentially, you know, you can just about use those interchangeably, cause more bridge collapses than every other cause combined. So I think that's a very, very powerful statement. So for the routine inspectors, you know, there's a certain things related to scour that they're responsible for. And one thing they are not responsible for is generating scour documentation. So by that, I'm talking about analyses, evaluations, summary sheets, those kinds of things. But in the inspection process itself, scour is certainly part of that process. So they are responsible for reporting, you know, observing, documenting, reporting if scour is occurring at a bridge, you know, and if it is it brand new scour? Did it happen since previous inspection? Or, you know, is it changing? Is it getting worse? Maybe some channels moving back the other way and scour holes are filling in, or, you know, maybe there's been some repairs, or is it unchanged? Maybe it's been that way for many, many cycles. Does the current scour documentation meet the requirements, you know, for scour documentation for that particular bridge, that type of bridge, and that's laid out in the scope? Are the site conditions, you know, is the scour that's out there now, or the lack of scour, are those current conditions represented in the scour documentation that's in the file? And you know, what we're getting at there is we want to know if a new analysis or evaluation is required, right? That's kind of the kicker with that. And of course, we're in the middle of moving to the NBI, I mean the SNBI. We're essentially doing double inspections, double data collection. We are still required to report to the FHWA our data in the old NBI, format, but we're also collecting SNBI coding. And as far as Scour goes, item B, point C, point 11, the Scour condition rating, that is somewhat similar to item 113 under the NBI, but this is, instead of an appraisal that has to be done through analysis, you know, this is observation of site condition or using information that's in the Scour summary sheet, if that's available. And then Scour vulnerability, this item is very, very similar to the Scour tab on the list of structures that we currently require. So it's really just a documentation review. The Scour responsibilities are pretty well laid out in the scope, the routine inspection scope. So I've addressed a few of them here. Well, I guess this is really pretty much all of them. Channel cross-section measurement record, right? That's not just doing your measurements on the upstream side, but also in the course of inspecting that bridge, you're looking for Scour. And if there is Scour, we need additional measurements. You know, what's the location, what's the depth, what's diameter, or, you know, what have you. And then photographs, you know, we want a picture of it. You know, if it's available, it may be completely submerged. But that's where those measurements come in handy. And, you know, you can plot that and show what's happening. Then the Scour documentation check, you know, in the scope, it explains what proper documentation is. And this is all recorded on the list of structures if it's not meeting the requirements. On that Scour tab is where all this goes. And a reminder that this spreadsheet is to be submitted to the district with each submittal. And then also a cumulative version of that is to be sent to the district and bridge division at the end of the work authorization. And then addressing the SNBI data, we added that to the supplement, the recent supplement to the scope, that the data is to be collected and entered. Yep, so here is, I thought that was my last one, I forgot. Here's an example of what that Scour tab looks like. So all these bridges on here have something amiss, or something's lacking in the Scour documentation. And this is great information for the districts. They can use this to maybe do some of the documentation themselves, like if it's a culvert, you know, it's kind of the low-hanging fruit and complete a Scour summary sheet for culverts. They can use this information to determine which bridges need to be added to a Scour contract. And Stephen, I believe, yep, that was my last one.
Thanks, Mark.
Yep, thank you.
We'll move on to Bob Pearson. We'll be talking about our new QA process for bridge division and provide a recap of QC processes for districts.
Hello, my name is Bob Pearson. I'll be going over just exactly what Stephen said, a recap of the QC and a update to the QA process that we put together here at Bridge Division. Much of this is going to be a repeat of what has already been covered, but there have been a couple updates, so it makes sense to go over them here. So and by the way, this is really mostly only relevant to those at TxDOT, because the the QC performed for routine inspection reports is performed by TxDOT district bridge coordinators, or in some cases TxDOT bridge district engineer, bridge engineers at the district. So if you're on this call and you're not at TxDOT, this is really mostly relevant to those folks at TxDOT actually doing the QC. Okay, with that said, TxDOT bridge coordinators and bridge engineers in some cases perform at 10% before I got disconnected. Apologies for that interruption. So we made a few changes to the QC process. Essentially, we made a change to the 10% photo review by updating section 4, which is already QC of the NBI and Scour documentation. We just changed the wording a little bit there. And then we also changed we added a little bit of a process to the quarterly QC reporting, and we'll talk about that here. So here's the old language we had in our section 4 of the 10% photo review, the online AssetWise version. Essentially, it always had been the NBI and Scour documentation section, where during a photo review, someone would look at the Scour documentation. However, the wording seemed a little bit awkward, so it's been updated to be a little bit more clear and provide a little bit more clear direction, at least, to what is really expected to happen during this 10% photo review as it pertains to NBI and Scour documentation, really. So one, we want to verify that the bridge file in the Files tab has whatever required Scour documentation it needs. You know, a Scour summary sheet, plan of action if it's Scour critical, and then if it is Scour critical, if it does have a plan of action, the other documents that are required after that. And then two, like Mark had mentioned before, and I'll show another screenshot of it later, in that list of structures document, in that spreadsheet that we should be getting every submittal, in the Scour tab, really that is the place for the inspection consultant to provide some detail to what is missing, what needs to be updated, etc. So really doing this 10% QC is an opportunity to check that list of structures is accurate and it's being updated. And essentially, you should be cross-referencing when you're doing your 10% photo review. You should be cross-referencing whatever bridge you're working on with that list of structures to see if it, you know, crosses over a stream or a river or what have you, some sort of water feature, that it's in the list of structures if it is actually missing Scour documentation. And if not, you know, you'd want to put a comment saying, hey, you know, this should have been included in that list of structures spreadsheet, but it wasn't. You know, item 113 is coded as 6, so obviously it's missing some stuff. So a good time to touch base with a consultant. Maybe they need to touch base with their sub-consultants on and remind them to update that list of structures Scour tab. So here is a blank version, and Mark had already showed this before, but here is a blank version of that list of structures. And so there's, again, something that already been touched on. There is a good opportunity here in the Scour tab for a lot of detail per bridge, what's missing, what needs to be updated, etc. And there's even a comment column out here to the side that I didn't really have room to show. But this is really in the details, or in the weeds rather. And so we, you know, the Scour group, the geotechnical group, they'll use this document. It's also a good document for the districts to use, like Mark was saying. So on the QA side of things, what we're going to be doing at Bridge Division, starting with our next QC quarterly report, is aside from what we already do, basically just, you know, check the 10%, the 5%, the 2% totals against how many bridges are in the work authorization. We're going to do a cursory check on bridges that have had a 10% photo review, where item 113 is coded as a 6. Which of course indicates that the bridge is missing Scour documentation. We would expect those those bridges that have had that 10% folder review, where item 113 is a 6, to have a no in this section 4 answer, indicating that no, all the required items are not included. If they were, the bridge should probably not be coded as a 6, right, on item 113. And in addition to that, there should be some sort of comment if the answer is no, right, saying that, hey, here's what's missing, here's what we need. Is it or is it not included in that list of structures, which is, again, the QC part of things, where you're cross-referencing what the consultant turned in their list of structures against the Scour documentation included for the bridge. So doing this check of the bridge files and the list of structures will help us kind of remind everyone about that list of structures and how it really is used, and or how important it could be, or how useful it could be if it actually gets used properly to update TxDOT, the districts and bridge division with the information that we do know per bridge regarding what's missing, what needs to be updated, and what items are outstanding on our Scour documentation. So per the scope, that final list of structures, the cumulative version, like Mark had mentioned, should be sent to the Geotech branch. And in the contract, it says the Scour engineer. I think using the Scour at TxDOT.gov link is going to be just fine for that. That's sort of like a shared inbox I use. So like I mentioned before, this is just something now that we're starting, and really it is a pretty basic cursory check just to make sure that you know, we don't maybe rush through the 10% folder reviews too fast, and that we're paying attention to all the various sections, and in this case that we're paying attention to Scour documentation and if it exists and if it's current. So the next QC quarterly review is going to be April 15th, and that's going to cover stuff from June to August, right? Obviously, those QC reports would have been done way prior to this presentation, right? So the language would have been a little bit different, but we're still going to run that cursory check because, again, if item 113 equals 6, we would most likely expect there to be some comment about that, and it'll really just be a total. It's at this time for this first few really that apply before we've given this presentation. It's not like they're going to change the overall QC scoring, but it is going to be sort of a reminder that, hey, while you're doing your 10% folder review, maybe to slow down and take a look at the Scour documentation as well. We have posted on our Crossroads site under Bridge Division. If you go to Bridge Division and then the Field Ops section, and then go down to the Inspection section, we have posted a little guide, this one that's highlighted here at the bottom that says Asset-Wise QA Reporting Process Overview. We have uploaded a guide that basically lays out what I'm talking about here, as well as the current QC totaling process, where we take the number of structures in work authorization and take the QC reports that are in Asset-Wise and go ahead and grade each district on if they exceed compliance, if they meet compliance, if they're not meeting compliance, et cetera, et cetera. So it has all that language in there as well. So that's a new document that has been uploaded here. Take a look at that if you want. And again, like I said, mine is the shortest presentation. Apologies for the interruption, for me being disconnected, but that is it for me. Thank you.
Thanks, Bob. Appreciate you coming back, going over that information. Looks like we've got most questions responded to. Chunh, if there are any, or Ryan, if you think that there are any that we might want to talk to the larger audience, or feel free to bring those up.
Yeah, no, there was one that asked about countermeasure coding approach regarding, say, a non-designed countermeasure and how long that cycle needs to be. So that depends somewhat. It'd be difficult to give an answer, a definitive, like this is the exact amount of time, because part of it is like, well, if you have an event and it holds up well during an event that you can classify, that may be justification to be able to make a change there. So it's difficult to say in terms of the amount of time that passed. But again, what we're trying to do with that, and what the intent with that is that it is to ensure that it is functioning. So we do need to make sure that we do leave enough time there that we are confident that it is performing as we expect it to. So that's kind of the big thing. So there's not a specific time associated with that, but if you would like some commentary on that, or if you would like to for us to evaluate that to kind of help with those decisions, we're happy to do so.
Thanks, Ryan. There's one question in the chat box about who is responsible for updating the NBI and SNBI codes for Scour and AssetWise. There was a good response by Ryan regarding item 113. Bob, would you like to expand on SNBI codes, or Mark on SNBI codes? I think you touched on this, Mark, in your presentation, but maybe just recapping on the fact on who will be updating, say, BC 11.
Sure. BC 11 is to be completed by the inspector. Item 113 is still locked, the NBI item 113, and that's being updated by either the Scour consultants or folks here at Bridge Division, right? And a few other select folks.
Thanks. It looks like we've got responses to pretty much all the questions. Really do appreciate everybody joining today. And I guess I'll make one last call for any questions that are worth reinforcing. We'll post a copy of this presentation or a video of this presentation and a Q&A to from all of these questions that were asked to accompany that post. Not seeing any more questions. Again, just do appreciate everybody taking time to attend. It looks like we had over 300 attendees at one point. So thanks again for taking the time. Everybody have a good weekend, and we'll talk soon.